All right, using what we just talked about, does the picture on the right have enough information to prove that triangle ABC is similar to triangle DEF? And the answer is yes. Why? Angle A is congruent to angle D. Angle C is congruent to angle F. And then we use the third angles theorem. So since we have two angles that are like two pair of congruent angles, that forces the last pair, the third pair, to also be congruent. That's going to force angle B to be congruent to angle E. And then in similar triangles, remember, angles are congruent. Corresponding angles are congruent. And that brings us into our first postulate slash theorem, right? The angle similarity postulate below. So again, what's the bare minimum information we need to know that two triangles are similar? Well, just do they have two angles that are congruent? Do they have two pairs, or do they have a pair of corresponding angles that are congruent? If two angles have a pair of corresponding congruent angles, then the triangles are similar. Sweet. And then this is a side effect. Fact: if the angles in one triangle are congruent to the angles in another triangle, then the corresponding of those triangles are proportional. So the congruent angles force sides to be proportional. All right. So we're going to use the angle similarity postulate to prove that triangle HLI is similar to triangle HKJ. So notice how we have this big brown triangle, and then we'll say this little purple triangle. All right, something just to remember, that both of these triangles have an angle H. The purple triangle, the brown triangle, they both have an angle H due to reflexive property. Wow, neat, cool. All right. Furthermore, something we haven't talked about in a while, but this is great review, and this would be true for both remaining angles. But we have parallel lines, and let's just look at this as we have parallel lines cut by a transversal. Something we can't forget is that this angle and this angle are congruent. And we're going to be very specific on how we name this. We got angle HLI. It's going to be congruent to angle HKJ. Now, let me think about why is HLI congruent to HKJ? All right, something we haven't talked about in a while, but these are corresponding angles. All right. We have the corresponding angle postulate. All right, so we've proved that two angles are congruent. I and J, they are also corresponding angles. We could also use third angles theorem, but nonetheless, it says use the angle similarity postulate to prove that triangles are similar. Check. We're just going to put a green check mark because that's what we did. We just found two angles that are congruent. Thus, they must be similar. All right. So we're just going to practice some fundamental skills too about similar triangles, some of the facts we talked about, and do this problem right here. So we know ABC is similar to DEF. So notice how we're knocking out the angles right here. So measure of angle F. All right, well, we need to find that first. Well, notice how that's the last letter, C is the last letter. So corresponding angles are congruent, so I can quickly just say the measure is 68 degrees. Next, it says I need to find B. B corresponds to E. We don't know either of those. I'm going to pause on that just for a second. Technically, we can already do it, but in the process, we'd be finding angle A anyways. Angle A corresponds to angle D. Angle D is 62 degrees, so boom, 62. degrees. And then, well, if A is 62 degrees, remember, all the angles add up. So I'm going to be very thorough. I'm going to write the measure of angle B plus 62 degrees plus 86 degrees needs to equal 180 degrees, because that's what triangles at all the angles in a triangle add up to. All right. And then a bunch of math occurs. Measure of angle B is 32 degrees, and that's what angle E would be as well. I'll even write that there just for fun. All right. So 32 degrees. All right. So the corresponding angles are congruent. Now sides are proportional. All right. So triangle's a little sloppy. I'm gonna erase these circles. You don't have to, but if you drew it, keep the circles on your paper or screen, whatever. But now we need to find FE. What does FE correspond to? Well, it corresponds to BC, and we know that that lines up with 30. All right. What I do have is AC and FD as well. So I just looked at my picture and identified some more information that I have. All right. So AC. So I'm just going to do 18 over 30. All right. 18 over 30. Well, that 18 corresponds to 12, so 12 will be on top, and then FE is what I need to find. All right. So this is the ratio proportion I wrote by myself. Remember, like, all that matters is that we match up corresponding parts. Like, you could have 30 over 18 equals FE over 12. Corresponding parts still match up, it just flipped. You could have even also had, you could have said, well, the orange is AC and DE, I have those in orange. I could say, well, those are corresponding, so I could write 18 over 12 equals 30 over FE. All right, there's even more. There's one more I could write. I'm not going to spend the time doing it. Just realize, as long as you're careful and match up corresponding parts, you're going to be in good shape. Cross multiply, divide by 18. All right, FE equals, I think 20, but let me just double check. 20. All right. So same thing right here, same kind of problem. All right. Find the measure of angle M. Well, M corresponds to Q, which is 36 degrees. All right. Find the measure of angle P. Well, P corresponds to L. We don't know L. How do I find P? Something we can't forget is, boom, we have to see this in the middle. We know that this is also 106Y. These are vertical angles. Incredibly important. Don't forget them. We still use them. Still useful. All right, vertical angles. So then we have the triangle sum theorem. And just some quick calculations off screen is going to tell me that this is 38 degrees. All right. And then MN. So now this part right here is just matching up corresponding parts. MN, well, MN corresponds to QN. And then what two pieces of information? Oh, I know 30 and 33. So I'm just going to be very careful when I set up my proportion. I'm going to say MN, which is what I need to find, over 20, because that corresponds to 20 on the other triangle, equals 33 over 30. And again, this fraction right here, I can technically reduce that now. I just go ahead and use brute force. I just cross multiply and then worry about reducing at the very end. But if you like to reduce first, be my guest. 660. Then I'm going to divide both sides by 30, and I believe it's going to be 22. But let me just double check. Oh, I was right. What do you know? And then QM. All right. So same thing. This problem won't look too much different. Oh, just asking for QM. Actually, there's not even really anything else I need to do. That was 22. So the whole thing is 42. All right, we got some